Good morning, all. Thank you for attending this second session of the training program, the CNCOBA training program, which is addressing the problems that you were faced with in the second round of the 2021 Senior Mathematics Olympiad. Last week, we did the problem starting from number 25 backwards and came up to problem number 14, I think. And we didn't have sufficient time to finish it, and that is why we are holding this class to do the rest of the problems. I don't envisage that we are going to take too long. Maybe within an hour we should finish, but I do thank you for attending. I can see we have got a very small number of participants. So I presume that you are the guys who are wondering whether you've got, you're counting your marks. In other words, you want to see whether you got into the third round. All right, so with those few words, let's go straight to the matter at hand. And we will, I think this time we will start from problem 1. Okay, so the first problem is a scale with 2 pans will balance if 8 identical cakes are put on one side and 6 identical cakes on the other side, along with 0.0125 kgs of flour on the other hand, on the other pan. So the question is now, what is the mass of all the 16 cakes? Okay, let's just see what's going on here. You've got a pan. Let's draw this pan. Something like that. And you've got 8 cakes here. What is it? 8 cakes, yeah. 8 cakes on one side. And here you got 6 cakes plus 1/8 of a kg. 0.125 is 1/8 of a kg. So these two things balance, which means that the 1/8 of a kg accounts, if you take the 6 out, accounts for 2 of those cakes. So 2 cakes weigh 1/8 of a kg. 0.125 is 1/8, right? So because they balance. So there's an additional 2 will be equal to the 1/8, and therefore the 16 cakes, oh, I'm sorry. It's again a proportion. There are lots of problems on proportion. 16 cakes is 8 times 1/8, because 16 is 8 times 2. So you have, this is your answer. 16 cakes will weigh 8 kilograms. I mean, 1 kilogram. Okay, so the next problem says you've got this picture here, 4 rectangular fabric strips of length 10 centimeters. So the length of these strips is, each of them is 10 centimeters and width 1 centimeter. Okay, so let's just record that. So this is 1 centimeter. That's the width. Here too, you got 1 centimeter. And the full length is 8. No, 10 centimeters. Okay, now they are put flat on the table and the overlap at right angles as shown. What area of the table in square centimeters is covered? Okay, now we'll have to see which part of those 4 strips it does not touch the table. If you put the 4 strips on the table, then the area is 40. 4 times 10. Yeah, each strip is 10 square centimeters because 10 by 1. So there are 4 of them. So if you put them 4 flat on the table, it'll cover 40 square centimeters. So which part is not covered? Or which parts of the strips are not on the floor? Well, I can see this part here is not on the floor. The overlap. And there are 4 of them. And those are the only 4 which are not on the floor. So all we need to do is to see how much, what is the area of this? Well, it's quite clear that the area is 1 centimeter across. So this is, each of these is 1 square centimeter. And those, there are 4 of them. And we have to remove those 4 because that part underneath this is not used by the strips in the process of covering the table. So the answer is 36. Okay, so that's the answer to that problem. The next problem is we go on to problem 3. Okay, so problem 3, what does it say? It says a palindromic number reads the same from left to right. And from right to left. So if you read it forwards and backwards, you get the same number. If you read this 14541, backwards is also 14541. Okay, so that's a palindrome. The palindrome, this is a palindrome also. It shows on the odometer of your car. Okay, so you traveled 15,951 kilometers. And how far must you travel before the next palindromic number shows on the I don't know how you say it, odometer, or whatever. Okay, so the question is, you've got this as your palindrome, which shows how much more must you travel? What is in other words, what is the next palindromic number? Okay, there are no other palindromic numbers starting with 15, which is greater than this. Right? You want to know this odometer will be increasing. Because if you start with 15, these are going to be backwards, and there's no number bigger than 9. So nothing starts with 15. So we have to start with 16. All right, it's a palindromic number, 16, so the backward number will be like that. And you want to know the next time this thing appears. So it's 15,900. You have to choose the smallest number here in the middle, and that is 0. So that is the next time this odometer shows a palindromic number. You can see this reads the same forwards and backwards. And the question is, how far must you travel before you get this? So all you have to do is to take the new one and subtract from it the old one, and you get the answer 110 kilometers. So you have to travel 110 kilometers before this happens. So that's the answer to your question. Okay, let's proceed to question 4, or problem 4. February 14th, Valentine's Day, was on a Sunday, 2021. What are the last two digits of the first year after 2021 in which Valentine's Day will again fall on a Sunday? This is a kind of a common problem dealing with dates of the year. What we need to know is the number of days in the year. The number of days in the year is 365. So the Sundays will fall after every 7 days. So we have to see each, from this point, if you add 7 days, you'll get a Sunday. If you add 7 days, you get a Sunday. So you have to keep adding 7 days until you hit the next Valentine's Day. So let's see how many Sundays there are in a year. Well, how many weeks, how many 7 days there are in a year rather than Sunday. So if you divide this, you get 52 weeks, as we know, that's in a year. But you have 1 day extra. Because 364 is 52 times 7. All right, so after every 7 days, you get a Sunday. So 364 days after this, you'll get a Sunday. So February 13th, that's 364, right? 365 is one more, is a Sunday. Okay, which means that February 14th was a Monday. Now this is 2022, because we are going through 2021 and we go up to 2022, that's 365 days away. And then likewise, when you take the next one, 2023, for the same reasons, this will be Tuesday, 365 days in the year. And again, 2023 has got 365 days, February 14th, 2024 is a Wednesday. But at this stage here, you have to be a little bit cautious because now we are on a leap year. And this year has got February has got 29 days. So when you come to the 28th of February, you're adding 1 extra day. So 366 days later will be February 14th. So let's see, just see what happens. So February 12th, that's 364 days. 2024 will be a Wednesday. That's 364 days away. That'll be on a Wednesday. But you've got 366 days that we have crossed. So February 14th will be on a Friday. Now this is 2025. And now you don't cross any further leap years. So you'll have Friday, and the next year will be Saturday, 2026, and 2027 will be a Sunday. So the answer is, when next will it be fall on a Sunday? And they wanted the last 2 digits of the year in which this will be a Sunday, and the last 2 digits of 2027 are 27. So that is the solution to that problem. Problem number 4. So let's just go on to problem number 5. Okay, so here we are at problem number 5. A triangular corner with sides CD equals CE equals 10 is cut out from an equilateral triangle. So here you've got a triangle which is an isosceles triangle, and because both the sides are 10. But that allows us to, because we know that the large triangle is equilateral. So this angle here is 60 degrees. So this is isosceles, which means that the remaining two angles add up to 120 degrees. So each of them is 60. So this itself is an isosceles triangle. This little thing, I'm sorry, this little triangle is an equilateral triangle. So if we know these sides are 10, so this will have to be 10. Okay, the question is now, what is the perimeter of quadrilateral ADEB? So this quadrilateral, what is the perimeter? Perimeter means you're adding up all the sides. We already got one side is 30. We've got another side we just calculated is 10. And the equilateral triangle has got sides 30. So all the sides are 30 here. So from here to here, it's 30. This 10 here, if you take it out from there, you get 20 here. I needed this because this is another side of the quadrilateral under investigation. And for similar reasons, that side there is also 20. So now we have all four sides of quadrilateral ADEB. So its perimeter is simply the sum of the lengths of the sides. And if you add 20, 20, 30, and 10, 30 plus 10 is 40. 40 plus 40 is 80. It's 80 centimeters, not square centimeters. That's the perimeter. So that is the answer to problem 5. The perimeter of quadrilateral ABCD. By the way, this is actually a trapezium because this angle here, the equilateral triangle was 60. So these two angles are corresponding angles. So this line will have to be parallel because the corresponding angles are equal. So these lines are parallel. This figure here is actually a trapezium. Okay, so we go on to the next problem, which is problem number 6. Problem number 6 states that how many 3-digit numbers with digits from the set 2, 3, 7, 9 are divisible by 3? Okay, so we need to find 3-digit numbers. So let's just put the hundreds, tens, units here. We'll box them in like this. So we have to put 3 digits taken from 2, 3, 7, 9. Okay, now you want it to be divisible by 3. And there's a rule for the divisibility by 3. I think all of you know that. You simply add the digits and divide by 3. So we need to see whether the sum of the digits is a multiple of 3 for it to be divisible by 3. So you need to have 3 numbers from here which add up to a multiple of 3. Right? If you got 3 such numbers, then you've got a multiple of 3. So if you take 3 out of 4, you can remove 2. In each case, you're removing 1 at a time. So the digits you will use if you remove 2 are 3, 7, and 9. And that is, when you add them, you don't get a multiple of 3 because you get 19. So we don't use those digits. If you remove, the next number we remove is 3, then you're left with 2, 7, and 9. And you add them, you get 18. And that gives you a multiple of 3. If you remove the next number is 7, then you have 2, 3, and 9. And you add them, you get 14. And finally, if you remove the 9, you have 2, 3, 7. And there you're allowed because that gives you 12. Okay, so these the digits which go inside here are 2, 7, 9, or I can draw a very nice picture without having to use the other thing. 2, 3, 7. Right. So these two numbers are divisible by 3, but they are not the only ones. You can take any permutation, any arrangement of this, and the sum would still remain the same. It doesn't change. So all the permutations of this are all multiples of 3. And here too, all the permutations of that are multiple of 3. So how many permutations do you have? How many arrangements do you have of 3 symbols, 279 altogether? Well, you can actually write them all down, starting with 7, starting with 9. So you can start with either 2 or 7 or 9, and you'll end up with 6 numbers. So these give you 6 numbers, and these, like in a similar way, also give you 6 numbers. So altogether, you have 6 plus 6. They ask you how many 3-digit numbers are divisible by 3. So altogether, you have 12. Digits need not be repeated. So you say that digits need not be repeated. That can come in an argument like this. You say the first digit can be chosen in 3 ways. As we saw, you can choose it that way, or that way, or that with a 9 in it. And then once you choose your first digit, the second digit, you have 7 and 9. So the second digit can be chosen in 2 ways. And that's why you have 2, 7, 2, 9, 9, 2, and so on. The number of ways of choosing the first 2 is 6. But the last digit, once you have chosen the first 2, this cannot be chosen in. There's only one way of choosing that. So that's how you get 6. It's 3 times 2 times 1. So the number of arrangements is actually 3 factorial, which is 1 times 2 times 3. So the number of arrangements of 3 objects taken 3 at a time is 3 factorial. Like that, you can have the same argument if you've got 10 objects and you want to find how many arrangements there are in 10 objects. Much more, it's 10 factorial. 1 times 2 times 3, the same argument works. So these considerations will be dealt with in grade 12, I think. When you do probability, you will certainly come across this particular principle. It's called a counting principle, that if you can do something in 3 ways, the next one in 2 ways, and the next one in 1 way, the total number of ways is 3 times 2 times 1 ways. The total number of arrangements of 3 objects is 3 factorial, and so on. Okay, so I just wanted to digress a little bit there because that takes you into something that you will do in grade 12. So I'm giving you a sneak preview. Very quickly I did that on how to count a particular kind of situation, how to count. Problem 7 says, what is the difference between the 2 prime numbers that add up to 1 less than the largest perfect cube less than 100? And that's quite a mouthful. I want you to interpret this question first. And what is the difference between the 2 prime numbers? Okay, just hold on with that a little bit. They add up to 1 less than the largest perfect cubed less than 100. So you need to work out the largest perfect cube less than 100 first. So what are the perfect cubes? It's 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. Now you can see from this point onwards, they're not allowed because you're looking at numbers which are less than 100. And the largest perfect cube less than 100 is 64. Right, so you start here now. The largest perfect cube less than 100 is 64. 1 less than that is 63. Right, now the question arises. What is the difference between 2 prime numbers that add up to this? You've got 2 prime numbers which add to 63. You've got 2 prime numbers which sum to 63. And the question is, what are the 2 prime numbers? Now, prime numbers are odd So the sum of two prime numbers will be even. So is it possible that you can have the sum of two prime numbers equal to 63? All right, so let me just take a break here and ask about this. Okay, we have a few more people who have come in. Welcome, Maga. And
Morning, Prof.
good morning, Maga. Good morning, newcomers. I don't know what time you came in, but I could hear the doorbell ringing at each time you entered. Okay, we are doing problem number n. I'm not sure what it is, where n is greater than 1. And we are saying that you got two prime numbers which add up to 63, and prime numbers are odd. So when you had two odd numbers, how can you get 63? What is the way out of this? Anybody wants to put your hand up? One person. You can use Faizan. Are you Faizan Ghani? Do you want to volunteer? Oh, Faiz. Faiz? Anybody wants to say which two prime numbers add up to 63? What's going on here? Saturday morning blues. No one?
So it could have been 2 and 59. Sorry, 2 and 61.
Yes, Sama. See, you cannot have two. That's well done, Sama. Sama Talib there was. You cannot have two odd numbers adding to 63. So you have to have one of the prime numbers must be 2. But there is only one prime number which is even. This 2 has got a very, very important property. In fact, the fact that it is an even, this is the only even prime, you get a lot, it's a very, very naughty prime number, 2. It gives a lot of problems to when you do higher mathematics. That the only even prime is it's a big bugbear. And you can make statements about the other prime numbers, although there are infinitely many, but when it comes to 2, God forbid. So it's 2 and they're adding up to 63. So it's 2 and 61, is it? Those are the two prime numbers. Oh, okay, it's 2 and 61. But the question is, what is the difference between those two prime numbers? Right? What is the difference between the two prime numbers that add up? So the two prime numbers are 2 and 61. The difference is 59. All right, I didn't write anything down there, so so 63 is the only way, what you call a decomposition of 63 as a sum of two primes. This is unique. There's no other decompositions. And the difference between those two is 59. And that's the answer. Okay, so let's go on to problem number 8 now. Problem number 8 says the number 126 can be written as the sum of two different prime numbers in several ways. Oh, they are still emphasizing this prime number story. Previously, we had a sum of two primes. Now there's a difference. So 126 can be written as a sum of two different prime numbers in several ways. Find the largest difference between two such prime numbers? Well, you can write this as the sum of two different prime numbers. So let's see. So both the prime numbers will have to be odd, obviously. If one of them is even, then you can't have 2 plus 2. That's only the even prime number, and they're different prime numbers anyway. So let's start with 3. 3 is a prime. The other number is 123, but this is not a prime number. 123, 3 goes into it exactly. All right, let's get to the next prime number. 121, that's not a prime number, it's 11 times 11. So this is testing your factorization, your bonds, all right? Actually, the 7 gives you 119. You might be tempted to say that this is a prime number, but it isn't. 7 goes exactly into this. So you'll have to eliminate that. The next prime number is 11, and you get 11 plus 115, which clearly is not a prime number. The next one is 13. 13 and 113. And this thing here, you have to check it out. This is a prime number. Okay. So we've got a sum of prime numbers, but we want the largest difference. You see, that is why I started with the small ones first. As long as you start with small ones, you're going to get a very large difference. So the largest difference will be 113 minus 13. You have to start with small primes to get the largest difference because they both add up to the same number. Okay. Now, just there are two interesting things I can say about this particular problem. For your edification. You see, 126 is a sum of two different prime numbers. There is a very famous unsolved problem that if you take any even number, not just necessarily 126, take even number, you can always write it as a sum of two different prime numbers. Two different prime numbers, any even. I'm not sure whether it's different, but you can always write it as a sum of two prime numbers. And let's take any even, take a number like 30, right? I can see immediately it's 17 plus 13, see? Okay, you also have 11 plus 19. You have 7 plus 23. So there are many ways in which you can write this, but the conjecture is that there is at least one way, see? Like 113, we found at least one way. And the conjecture is any even number. If you take, for instance, 1,000, I'm just trying to work this thing out quickly. It's 491 plus 509. I know that these two are prime numbers. They add up to that. See? But the conjecture is any even number. Now, let's see. That's one thing. It's called the Goldbach conjecture. If you Google it, you will see that it's an unsolved problem. All the greatest mathematicians in the world have not been able to prove that any even number. They've tried it out, by the way, to very huge numbers, with 60 digits, or maybe not 60 digits, maybe 20 or 30 digits, and they found that none of those even numbers defied that rule. Every one of those were seen to be a sum of two prime numbers. So it's very likely to be true, but we still don't know whether it is true. Okay. The other statement I wanted to make about this is the other statement I make is the distance between two consecutive prime numbers. Okay? The distance between two consecutive prime numbers. If you take, for instance, take the number 29, the next one is 31. So the distance between these two prime numbers is 2. That's the shortest distance you can get between two prime numbers, obviously. And two consecutive numbers can't be prime because one of them is even. If you have two consecutive numbers, one of them has to be even, so they both can't be prime. Now this one here, where they're different, the shortest distance, this is called a pair of twin primes. 29, 31. Let me just go to the whiteboard here because I'm using up all the space. The whiteboard. I just thought I might share some interesting things with you. We were talking about the distance between prime numbers. So you got 29, 31 is an example of twin primes. They are only 2 apart. There are many other twin primes. Let me see, what is the next one? 37, 43, 47, 53, 59, 61. This is the next pair of twin primes. See, and you can get very large pairs of twin primes. For instance, I can see that 1019 and 1021, I think both of them are primes, and that's a pair of twin primes. So that's another unsolved problem. How many twin primes do you have? Are they infinitely many? See? In other words, are there infinitely many pairs of primes which are separated by only 2 units? That means infinitely many primes which are very close to each other. Right? That question is also an unsolved problem. There are lots of unsolved problems in number theory. If you solve any one of them, you'll become world famous. Okay, this is one of them. So the Goldbach conjecture was that every even number is a sum of 2 primes. And this one here, I don't think it's got a name. I think it's called the twin prime conjecture. They're called twins because they're next to each other. Okay, so that's also an unsolved problem. All right, so let's get on to problem number 9. Problem number 9 is, let's take a new share. Just bear with me while I move my screen. Okay, problem number 9 is this. They got these 4 famous mathematicians. They all took the same test. I don't find this particular problem very amusing because you take 4 great mathematicians, and they're all writing a test, and some of them got more than the others. I don't think it's fair to compare great, brilliant, mathematicians like this against each other. And the second thing is they all didn't live at the same time, so it is impossible for them to take the same test. But the last thing is that it just happened that these 4 guys, which they took at random, they happened to have the same surnames as famous mathematicians, which is highly unlikely to be all in the same class. Whatever. Somebody wanted to be a little bit clever by using these names. Okay, let's just get on to the problem. Let's call these guys P, N, G, and F. to be, and they all took the same test, so they got marks. So let these represent the marks of these people. So P is the mark that Pascal obtained, and so with Newton and Galileo and Fermat. Now, Pascal, the average mark of the 4 candidates was 16. Now, we've seen averages many times. When you got average, it means that when you add them, you're going to 4 times 16. So that's an equation, right? If you know the average, you got an equation. The sum of the numbers equals 64. That's your equation. Now, Pascal and Newton, their average was 16. So when you add their scores, you're going to get 32. And Pascal and Fermat, they had an average of 13. So when you add their scores, you get 26. And Newton and Fermat, if you add their scores, you get an average of 18, which is 36. And the question is, what is Galileo's score? Now, you got 4 unknowns here, and you might argue, hey, we've never ever done a problem. 4 unknowns, 4 equations with 4 unknowns. We did 2 equations with 2 unknowns, just not even 3 equations with 3 unknowns in school. But now they're asking us 4 equations, 4 unknowns, very unfair, and so on and so forth. Actually, there is a way of doing this thing, very clever way. When you look at these 3 equations, you'll see you got 2 F's, and you got 2 P's, and you got 2 N's, right? So a nice thing to do would be to add all of them to get 2P plus 2N plus 2F. When you add up all these, you get 32 plus 26 plus 36, 14, 9. So this gives you 94. Now that is 2P plus 2N plus 2F. So if you take only one of each, you're going to get 47. Right, so P plus N plus F is 47. So there you have it. You got that these 3 guys, when you add them, you get 47. So the one who is not present, the G, would have to be 64 minus 47. Right? 3 of these add up to 47, so the 4th one will be 64 minus 47. So the answer 64 minus 47 is 17. So that's the answer to question problem number 9. The answer is 17. All right, let's get on to the next problem, which is problem number 10. I'm going to post all these as usual. I'll post the PowerPoint presentation, the entire one, right, from 1 to 25 on the Google Classroom platform, and you can have it available. I'm going to ask David Ramaboka to do that as soon as possible. We didn't put it up until now because we still had these 10 problems to look at, and I wanted to give you a chance to try them before we come to this meeting, so I didn't want to post those problems. Now that we'll be finishing it, certainly we will post it. And also the audio recording will be available for those who didn't pitch up. Okay, the number 2021 is a product of 2 successive prime numbers. What is the sum of these 2 prime numbers? Now, 2021 is the year in which we are. I think all of you should know that it's not a prime number, but I don't think I mentioned it in any of my classes. So so this is a product of 2 prime numbers. In other words, it is not a prime number, it is a product of 2 prime numbers. And what is the sum of these 2? But they are successive, you see, consecutive. In other words, these prime numbers are quite near to each other. You've got two numbers which are being multiplied, and they are quite close to each other. Now, how do you find these numbers? Because they are successive. The trick is, well, if they're quite close to each other, then they're probably approximately equal to a square number, right? They're quite close to each other. So your n squared is approximately 2021. Actually, 2021 is equal to this product, and that's approximately equal to n squared. So now the question is, which number squared is very close to 2021? And some of you will know that 2025, that's 4 years' time, that's a square number. So if you guys are around at that time, I'm not sure whether I will be, but just recall that you'll say, wait, 2025 is a square number. It's actually 45 times 45. Okay. To digress a little bit, let me just tell you. Okay. So this is approximately 45 times 45. So let's look at a prime number less than 45 and a prime number greater than 45. Right? That will give you some number which is approximately 45 times 45. And a prime number less than 45 is 43. If you take 2 away from there, if you add 2, you get 47. And these two are prime numbers. And if you multiply them out, you get 2021. So that's these are the numbers that we're looking for. So there's a way of actually finding what these prime numbers are. That is what I'm telling you, that it's approximately 45, both of them. So you just look for one which is slightly less than that and another which is slightly more than that. And you have the factorization. The sum of these two prime numbers is what they ask for. Always answer the question. 43 plus 47 is 90. I said that I need to say something an aside regarding these. And so if you say this 2021, that's the year in which we are in, we could have factorized it in another way by observing that it's 4 away from a perfect square. We are 4 years away from a perfect square. And then if you bring the 4 to this side, you get that. And this is a perfect square, you see? So it's 45 squared. And this is minus 2 squared. And that's the difference of 2 squares. And any difference of 2 squares you can factorize. And that's how you get 43 times 47. We could have got this by observing that we are 4 away from a perfect square. That's the first thing I wanted to tell you. And the other thing is 2025, when you divide a number by 25, suppose you're dividing 725 by 25, right? I have a very quick way of doing it. I say this is 7 times 4 plus 1. Why? Because this is 700 plus 25, and each 100 has got 4 25s in it. So 700 will be 7 times 4, right? 28 25s in 700, and you got one more, that's the 28, this one more is, so that's 29. So there are so many 25s in 725. So the number of 25s here is 20 times 4, which is 80, plus 1, which is 81, and that's a perfect square. That's 5 times 9 squared. So that's another way of doing it. Okay, so you can, there are quick ways of seeing which numbers ending in 25 are perfect squares. You simply multiply the first two digits on whatever digits appear before that by 4, then add 1. If you had 775, then you add 3 now, because there are 3 25s and 75. So it'll be 7 4s, again 28, plus 3. So 775 divided by 25 is 28 plus 3, which is 31. So that's how I divide by 25. And to multiply by 25 is very easy also. If I had 169, I'm multiplying by 25. Right? It's simply 169. 25 is 100 divided by 4. So I just have to divide this by 4. So when you divide 169 by 4, you get 4, 2, 42. Remainder 1. And the remainder 1, I just make it as 25. If I add the remainder 2, I'll put a 50. If I add the remainder 3, I'll put 75. So these guys are shortcut methods of doing sums, working with numbers. And I thought I might just share some of my tricks with you, because a lot of people, they want to know, how come, Prof, you work this thing out so quickly? I have a couple of tricks in my bag. Okay, let's get back to this problem number 11. Problem number 11. Okay, so what does problem number 11 state? It states that what is the least possible perimeter of a triangle whose sides are consecutive square numbers? Okay, so the sides of this triangle are consecutive square numbers. Now, what are the consecutive square numbers? You could have 1 starting with 1. The next square is 4, 2 squared, 9. Now, the question is, what is the least possible perimeter of a triangle whose side lengths are consecutive square numbers? So you might think that the answer is, well, the smallest possible perimeter has to be a 1 here, 1 squared. So the answer is 14. But this cannot be the answer, because there's no triangle like this. There is a famous, very important fact, which is called the triangle inequality. Very important. The triangle inequality says that the sum of two sides of a triangle is always greater than the third side. It's always greater than the third side in any triangle. You see, the reason for this is, if I got 1, 4, and 9, right? Suppose I want to draw this triangle. What do? Okay, let's draw the 9. Right. Now I want the other two sides to be 1 and 4. So the vertex now, the third vertex of this triangle, will be 1 unit away from this point and 4 units away from this point. So what do? You take all the points which are 1 unit away from this point here. All of them will lie on a circle of radius 1, right? So it'll hit this line here at 1. Now here, when you draw a circle, you have to see all the points which are of radius 4. Right? Now, you see, I got 1 here and I got 4 here, and you're not going to make up 9. So these circles don't intersect. So there are no points which are 1 unit away and 4 units. There are no points because they don't intersect. For them to intersect, you will have to have this to be large enough. Sorry, however, this radius plus 4 must be greater than 9. That's why you have the sum of two sides of a triangle is greater than the third side. Okay, so to get back to this problem here, 149 is out. The next one is 4, 9, 16. Right? 4 plus 9 is 13. Doesn't work. So you don't have a triangle with 4, 9, 16. The next one is 9, 16, 25. And this one here, you don't get a triangle. The 9 plus 16 gives you exactly, when you draw the circle, they just touch here. 9 and 16 gives you 25. So you don't have a triangle here. So the first one is 16, 25, 36. 4 squared, 5 squared, 6 squared. And there you see, you can certainly draw a triangle like this because the sum of two sides, any of these two sides is greater than the third. So that's the answer. And the perimeter, the least possible perimeter is the sum of these numbers, 16 plus 25 plus 36. And that's 77. Okay. So let me just say, I don't remember 77. I wrote this. Let's check this thing out. Yeah, okay, I got the 77. Okay, so let's just go on to the next problem. So now we look at problem number 12. Problem number 12, it speaks about two containers which have the same volume. Okay, let's just draw these containers. I always like to draw a picture whenever you got something there because that gives you what I call a concrete realization of the abstract. In a lot of mathematics, we do draw pictures. So they got the same volume. So I'm going to make these two containers to look the same because they got the same volume. So water flows, you're calling them P and Q. So water flows into P at the rate of 4 liters per minute. So water is going in here at 4 liters per minute. And into Q also, here you got 6 liters per minute. Q at the rate of 6 liters per minute. So there's more water flowing into this than this in a single minute. Now after a certain time, container P can still take 60 liters. So P is still not full, but it can still take 60 liters. In other words, the extra volume is 60 liters here, right? But Q has overflowed by 10 meters. So there's been an overflow outwards by 10 meters. 10 what? Of 10 liters, yeah. Okay, so while this thing has still got 60 more to go, this thing has overflowed by 10 minutes. What is the volume of each container? Very interesting problem. I always try to look for simple solutions to problems. You notice that I hardly ever use the whiteboard. Everything is just done on this thing here. So there's not much calculations involved. Now you can use calculations. I think the official one has got X's and Y's and all that. But I can do this without any X's and without any Y's, which I always look for solutions like this. Now here's the argument. It's quite subtle. Why is it that this thing has overflowed and this thing is not full? The reason is because the 6 is bigger than 4. That's the reason. It's bigger than 4 by 2. So what's happening is that this thing has got 2 liters more per minute than that one. This thing fills up by 2 liters more in 1 minute than that one. Now, you still had 60 to go, and this thing went up by overflowed by 10. So therefore, there was 60 plus 10 extra liters. Because the 60 here to reach this point, and this thing had gone up by another 10, as it were, if it was a larger tank. So it would have been 60 plus 10. So the 70 liters, right, is as a result of 2 liters per minute. That's the extra. Which means that this water has been flowing. For each minute it was gathering 2 liters extra. To gather 70 liters, it would have taken 35 minutes. So in other words, water has been flowing into this thing for 35 minutes. The question is, what is the volume of each container? Right? Water has been flowing for 35 minutes. And so you can do it like this. This thing is 4 liters per minute. So in 35, you would have had 35 times 4. This thing would have taken 35 times 4 liters. That's 140. But you still got another 60 to make up the volume. So the volume is 35 times 4 plus 60. 35 times 4 is 140. And if you add 60, you get 200. So the volume that you're looking for is 200. Or you could have taken this one here. Now there's 6 liters per minute. In 35 minutes, it would have been 35 times 6. And that's 210, right? But 10 liters overflowed. So the actual volume is 210 minus 10, which is again 200. So you could have done it either way. Without X's and Y's. I'd like to just find out from you guys. How do you like that solution, guys? Faiz liked it. Sutirtha liked it as well. That's good. I don't know whether you got the answer 200. How many of you did get 200? Okay, Faiz has got it. Sutirtha as well. Okay. So how did you guys do it? Did you use symbols? Sutirtha?
Yes, Prof, I did it with symbols.
With symbols, huh? Yeah. But don't you think this one here without symbols is quite neat?
Definitely, this one is elegant.
Elegant, that's the word. Right. So this is what problem solving is all about. To find some method of solving a problem just using your logic and understanding what you mean. You see, here you are interrogating, what do you mean by liters per minute? So in 1 meter, in 1 minute, you got so many liters. So you understand precisely what it means. In every one of these problems, even rates, you've got kilometers per hour. You must say, in 1 hour, you travel 60 kilometers. You have to get that feeling in your head. Then only you'll be able to, get to the bottom of the problem. Okay, so let's get on. The next one is, I think we're getting to the last problem now. I really abused the time because I told you I'm not going to take too long. But this last one is quite silly. Okay, I'm not even going to do it. What it says here is that you see all these dotted lines. This 20 represents the sum of all these numbers here, and 13 represents the sum of some numbers on the other side, and 4, something like that. And this is a Sudoku problem. The Sudoku problem means the whole 9 squares add up You put the numbers 1, 2, 3, 4 up to 9 are inserted here, and these numbers add up to 20, and those add up to 16, and so on. So this is a Sudoku problem. So they ask, what is this X here? Right? And it's, as I said, it's a kind of a silly problem, because I think they were just trying to mislead people to give too much of unnecessary information. But in a way, that's a good thing also, because these 5 squares here add up to 20. These 3 squares here add up to 16. And if you include the X, then you're adding all the numbers from 1 to 9. And that by now you should know is 45. The sum of 1 to 9 is 45, up to 10 is 55. So this is 20 plus 16 is 36. So X is 9. Okay, so with all the long story here, you can cut it short. This 13 is not used, 4 is not used, 11 is not used. This is all just to confuse you. Okay, and Sudoku is this game where you play with 9 squares, which have 1, 2, 3 up to 9. Okay, guys, I took more than an hour, 1 hour, 10 minutes to be precise. Thank you very much for listening. You can stay back if you've got something to tell me about. Or, we will continue these classes, but maybe it will be much later, maybe in July or something like that, middle of July. But some of you or many of you would get into the 3rd round, I think. So I will continue to, I would not call it 3rd round training. It's impossible to train people for 3rd round because you have absolutely no idea what kind of problems come up there. But we will try to expand your mathematical knowledge when we meet. I'll give you more important facts. Maybe we'll have more lessons to develop your mathematical toolbox, right? So that when you come across some of these more challenging problems, you'd have more tools to work with them. Okay, so if you want to leave, you can leave, and those who want to stay behind to talk to me, you can. And if you want to put something in the chat column, please do so. All right, so I'm going to now stop the recording.